So, what's the observable universe? Basically, it's the part of the universe we can actually see with our telescopes and stuff. But there's a catch. Light, how we see things in space, only goes so fast. This means we can only see things that are within a certain distance from us. We can't see stuff that's super far away or happened way in the past. The observable universe is huge, like 93 billion light-years across. That's way bigger than the universe's age, about 13.8 billion years. How can that be? Well, the universe is expanding. Things that used to be closer are now moving apart like crazy, and it takes light longer to reach us from those objects. It's a massive place, but we're still figuring it out. Telescopes like the James Webb Space Telescope are helping us learn more about what's out there. Check out the new structures that the awesome James Webb Space Telescope has discovered recently. If you want to stay updated on space news, subscribe to our channel. Like this video and hit the notification bell. What's beyond the part we can see? To get to the very edge of the observable universe, we'd need some crazy tech to bend space and time, kind of like warp drives or wormholes. Some scientists are unsure about the possibility of faster-than-light travel. Even if it's possible in theory, we'd need tech that's way beyond what we have now. There's a theory called cosmic inflation that says the whole universe might be at least 10 to the power of 23 times bigger than what we can see. That number is pretty much impossible to imagine. Since we can't see or measure the unobservable part, we can't know for sure what's out there. But that doesn't mean we can't make educated guesses based on what we do see. That's where NASA comes in. NASA and other space groups have really boosted our understanding of the universe. Even before the James Webb Telescope, the Hubble Space Telescope shared some awesome images of super-distant areas. Recently, when the James Webb Space Telescope has made its debut, the most distant galaxy was observed by it. These super-old galaxies were shining like crazy millions of years after the Big Bang. The universe has been expanding, stretching light to redder colors. The James Webb Space Telescope can pick up infrared light. This helps us see how galaxies were forming way back when the universe was young. The James Webb Space Telescope stared at galaxies at a distance to see how quickly stars were forming way back then. The data shows that lots of galaxies were making stars back in the early universe. It's mind-blowing. Humans have always wondered if we're alone in the universe. But now these new findings make us think that there must be millions of other galaxies. Are there aliens out there? The argument for life beyond Earth is getting stronger. We've found tons of planets outside our solar system, exoplanets, using methods that show us the planets may have a similar environment as Earth and also could harbor life. The James Webb Space Telescope spotted water molecules on another exoplanet called WASP 96b. It even saw signs of clouds, which we didn't think were there before. With all the places that might be able to support life and the work being done to find exoplanets, it's hard to turn down the chance that alien life might exist. What about the multiverse? It's possible. The possibilities are limitless. Okay, so the multiverse, also called the many-worlds interpretation, is this idea that there are other universes besides our own. It comes from quantum physics, which is all about tiny particles. The idea is that when we observe something, the system splits into multiple possibilities. Keep in mind the idea of a multiverse is still very speculative. It's hard to say for sure if it's real or not. Since we don't know what's outside our universe, the idea of a multiverse is valid. Does dark flow exist? It is a complex question. Back in 2008, some scientists thought they saw galaxy clusters moving faster than they should, based on how matter is spread out in the universe. The idea was that some dark matter or energy was pulling them in a certain direction, dark flow. But other scientists aren't so sure. Some recent studies haven't found any evidence of dark flow, or they think the galaxy clusters might be moving that way for other reasons. It's still up for debate. What do you think? Let us know in the comments. Like and subscribe, and see you in the next video. Dark matter and dark energy make up about 95% of the whole universe. We haven't been able to directly spot either of them. The more we explore, the more questions we uncover. The universe is vast and crazy, and there are still many mysteries. From dark matter to alien life, we may understand the cosmos within our lifetime. Will we ever reach beyond the observable universe? Who knows? But the idea, no matter how out there it seems, speaks to our urge to explore. With our current tech, getting to the closest star system would take tens of thousands of years. To escape the bounds of our universe, we'd need some major breakthroughs in how we travel and get energy. Warp drives is one idea for bending space to travel. Even better, using wormholes would theoretically make the trip much faster. Whether it's with these ideas or something we haven't even thought of yet, our kids or our grandkids may one day reach beyond what we can see now. What about AI? As our AI gets better, these algorithms are already helping us by analyzing data from telescopes to help find exoplanets. AI tools are being used to simulate galaxy formation. As our telescopes get better, the amount of data will increase exponentially. Without AI, it would be difficult to process and interpret all this information. In the future, AI could go to remote locations, which would allow us to make real-time decisions. So, what's the observable universe? Basically, it's the part of the cosmos we can actually see with our telescopes. We can't see everything because light, which brings us info from space, only travels so fast. This limits how far back and how far away we can look. The observable universe is huge, like 93 billion light-years across. That's mind-blowing when you consider the universe is only about 13.8 billion years old. How can it be bigger than its age? Well, the universe is expanding, so things that were once closer are now much farther apart. It takes light longer to reach us from those distant objects. Even though it's vast, there's a crazy amount we still don't know. But we keep learning, especially with powerful telescopes like the James Webb Space Telescope. We're figuring out more about what's out there. Keep checking our channel out, where we will talk about the new structures that the James Webb Space Telescope has just discovered in the far reaches of space. Subscribe so you can get the updates. Like and share the video as well. What's past the observable universe? To get there, think warp drives or wormholes, stuff that bends or shortcuts space. Scientists argue about whether that's even possible. Some say it clashes with the speed of light thing, or is beyond what humans can do with tech. Cosmic inflation theory suggests the whole universe is at least 10 to the power of 23 times bigger than what we can see. That's too big to even imagine. Since we can't see or measure it, we can only guess what's out there. This doesn't mean we can develop theories about from data we collected from galaxies. That's where NASA comes in. They do some crazy work out there. They show us all kinds of shots of galaxies with the Hubble telescope, and even cooler shots with the James Webb scope. The new space telescope has spotted galaxies super far away from when the Big Bang happened. Since the cosmos is getting bigger, they look redder, but the James Webb Space Telescope can see this, and it shows us galaxies forming super early on. It figures out how fast stars were born way back when. Pretty wild, right? For ages, people have wondered if we're alone. This stuff we're learning makes you think there must be tons of galaxies we can't even see. It makes you wonder if there's life out there. We've found planets like ours, called exoplanets, and some could have life. There's water on them and stuff. Another exoplanet known as WASP 96b was found with water vapor, making people more inclined to believe the planet is habitable. A lot of stuff is up to debate with other scientists, however. It makes you think of the possibilities in the universe. The idea of a multiverse, tons of universes, is out there, too. It comes from how tiny particles act. The thought is, every time something happens, the universe splits, and each split is a new possibility. It's a crazy thought experiment, but there's not concrete evidence to prove this. Is it valid? Who knows? Much like Schrödinger's cat. Then there's dark flow. It came about when scientists realized that galaxies are moving faster than normal. They think dark matter or dark energy is pulling them. Though it is not for certain if this is the case. This topic is very complex. One of the biggest mysteries is dark matter and dark energy. They make up 95% of the universe. We have not yet detected them, unfortunately. The future is very bright with what we might find and what it will lead to. Will we go past what we can see one day? It seems really hard right now or impossible. Even going to the Alpha Centauri system would take tens of thousands of years with our fastest spaceship. Some believe that we can use warp drives to travel faster than light. The energy amounts needed for that would be crazy high. Even the thought of wormholes has been a hot topic or debate. AI is useful in space. It goes through the data from telescopes, helps spaceships cruise around, and even finds planets beyond our solar system. NASA's Kepler and TESS have found many exoplanets using machines, and AI is modeling galaxy birth. Dark matter is given thanks to new models, and tells us what cosmic events could occur. Without AI, it'd be really hard to look at all the info and figure everything out. AI could help spaceships make choices on their own way out in space.